Hi, everybody. Now let me start correcting the review exams. So here, according to the graph, we see that when x approaches -1, the f of x approaches to this point at 1. F at -1 is here, 2. F at 2, you can see here, is this point, -2. F approaches to 2 from the left-hand side, so the limit will approaches to 4. When x approaches 2 from the right-hand side, f of x approaches this point at 1. When x approaches to 2, it does not exist because the left-hand limit and the right-hand limit are different. So when x approaches 3 from left or right, the limit are both infinity. When x goes to infinity, y will approaches to 0. It's not very easy to see here, but we see that the train is approaching to 0. When x goes to negative infinity, the graph here will approaches to 0, the similar story. So we see that there are 3 points that the graph is not continuous. The first one is at -1. The second one is at 2. Third one is at 3. At x is equal to -1. This is a removable discontinuity. Because we can remove this discontinuity by defining a value at -1 to be 1 right here, this point. That is why it has that name. At x is equal to 2 here, we see that the graph, there's a jump from 1 to 4. Therefore, it is a jump discontinuity. At x is equal to 3, when x approaches 3, f of x approaches infinity, so that is why we call it infinite discontinuity. Okay. And the vertical asymptotes are the 0 points of a radical function, or the the value when x approaches a specific numbers and f of x approaches to infinity. So we see that there is only one point when x is equal to 3. This is the line here. This vertical line, we call it a vertical asymptote. Right. When here, on the other hand, when x approaches to plus or minus infinity, y will approaches to 0, and this horizontal line is the horizontal asymptote. That's it for the first question.